When we start talking about mathematics in abstract ways, we start using numbers and symbols and operations to explain math. So here we aren't going to use any manipulatives. We're just going to use numbers and explain some of the things about multiplication comparison in ways that we've seen before, but maybe have not thought of. So get a blank sheet of paper and a pencil. These are our notes. Go ahead and turn these in when you are finished. Stop the video if you need to. If it gets complicated, then play it back a couple times until you kind of understand what's going on. This is actually pretty difficult stuff, but when you start looking at word problems, this is going to help you out tremendously. We are going to be looking at what are multiplication comparisons. We're going to look at a couple examples. And we're going to be getting into something that's a little bit more abstract. We aren't going to use items or manipulatives. We're just going to use representation of items and manipulatives and go further into just using numbers eventually. So we know comparisons means that's like a Venn diagram, right? And here's our units. We don't have anything right here, but that's what we both have in common. This is going to be me, and this is going to be you. Stop the video anytime to catch up. So if you aren't here yet, stop the video and take some time and go ahead and make a Venn diagram with me and you over here. And we're going to always go from the least amount to the greatest amount, or a greater amount. So I'm going to have, the thing that's going to be different than we're going to be doing comparisons on is I'm going to have a smaller amount than you. And I'm going to use a dot array. So we need to come up with a unit. So let's say this dot, one dot is going to equal one pistachio. We've used pistachios before, so let's go ahead and stick with pistachios. And I'm going to make a little column here, kind of a mini chart. This is going to be me, and since you are going to have more, we're going to give you some more space over here. This is going to be you over here. And I'm going to use a Lego platform. You can put Legos on top of these, and these have a lot of dots. So each one of these dots is going to equal one pistachio. So instead of having a bunch of pistachios over here, math is really a science of making things smaller and then arranging them in different ways. I'm just going to use this. And let's see how this works. If I set this up under here, let's see if I can find a dot. There's a dot. That kind of works. Can you see that very well? I'll come by and clean that up with an eraser. Let's say this is you over here. There's a dot. This is a little bit more funner than putting dots in. So I'm going to continue my array here. Speed it up a little bit. I'll see you on the other side. Okay, so I apologize for you having to make so many dots over here. You can pick one of these up at a dollar store, or maybe you already have one at home. Go ahead and put it underneath the paper, and maybe that'll take a little less time for you to make a dot array. So each one of these dots is going to equal one pistachio. So over here I have a 2 in our columns over here, and a 3 in our rows. And what do you think that's going to equal? That was relatively easy. It's a pretty small number. And over here is a little bit larger. 1, 2, 3, 4, 5, 6, 7, 8. Over here I have 8. And 1, 2, 3, 4, 5, 6. And over here I have 6. So if you do the math, okay, here's our rectangle. So we know we can use multiplication for this. This is obviously much larger than that. So if we do our math, we're going to find out how many are over here. Can you guys come up with that answer? What's the product going to be? If you said 48, you're correct. So now over here, we're going to use our math. We're going to use an equation to show these comparisons, these two items here. So just like we did with our pistachio, we're going to say, you have 48, and I have 6. Now we know these two numbers aren't equal. So how many times larger is this number? So it's going to be how many times larger is, and let's go ahead and use P again for pistachios. How many more pistachios do you have than me? Okay. So how can we solve this equation? What's P going to equal? Well, if you look at your array, you already could figure out, or if you know your multiplication, you could already figure out that P is going to equal 8. I have 6 over here. You have 48. You have 8 times more. Now, let's take our dot array, something that we've already done, and let's see if that's true. Here's one group of 6, 2 groups of 6, 3 groups of 6, 4 groups of 6, 5 times, 6 times, 7 times, 8 times. So our multiplication will go right here. Our multiplication symbol will go here. This is 6 8 times. And this is what our equation looks like. So how would we write that out in a short math statement? We would say you have 8 times, and I'm using the word this time, as many pistachios than me. Now, how do we do this in a ribbon model? So this is going to be getting really abstract. And I know I've shown you ribbon models, and you guys have done pretty well with it. But what would this look like? What would this look like in a ribbon model? This example here. Well, we know our 8 times has to go out here. And we know our 48 is going to go here, right? This is the total amount. Now this means we have to divide this ribbon into 8 equal boxes. So the way to do that is just to divide it in half first, and to divide that in half. Okay, so that gives us 4, and then divide that in half. And that should be 8. 1, 2, 3, 4, 5, 6, 7, 8. And what number is going to go in each one of these boxes? If you said 6, you're correct. So if I have 6 of something, and you have 8 times as many, putting a 6 in 8 boxes is 8 times as many. So I know that was really difficult. Let's look at something even more difficult. Let's give one more example. And let's use time. Okay? So let's say we're timing each other on who can go out and who's taking the trash out. Okay? And let's say Mr. Budinger, me, can take the trash out in 5 minutes. Okay, and we'll say that's 5 minutes. And let's say it takes you 15 minutes to take the trash out. Let's make a larger circle for that. Even though we're talking about time, we're using something abstract to represent time. And you're the greater time and I'm the least time. And our question would be, how much greater? How much greater is 15 minutes than 5 minutes? You could say, okay, as far as time is concerned, let's put T. We have that for time. Well, let's do the same thing. Let's use the 5, this is my time, and the 15, your time. Are these the same? And you'd say, of course not. They're not the same, Mr. Budinger. We say, how much larger is 15 than 5? And let's use T as time. Just remind us that we're talking about times, not pistachios. You're going to say, well, that's easy, Mr. Budinger. T is equal to 3. So we would say, it takes you 3 times, I'm going to use the symbol this time, more minutes, right? Because you're taking longer. This is more minutes than what I can do it in, to take out the trash. Than me. And if we were to draw a Venn diagram, what would that look like? Well, not a Venn diagram, but a ribbon diagram. Okay, we know the 3 times is going to go here, so we need 3 equal compartments. We know the largest number is here, the product. What would go in each one of these boxes? You said 5, you're correct. So I can do it in 5 minutes. That's a short amount of time. And it takes you 15 minutes, and that's a longer amount of time. So if we're comparing these two, I can do it quicker. So it's not always an advantage, especially when you're talking about time, to have a larger number, is it? Pistachios, yes. The time it takes you to do something, probably not. So here's 2 examples of how to use multiplication comparisons that are very different than each other and are quite abstract. Go ahead and copy this out. Stop the video whenever you need to. Review the video if you need a better understanding of it. But all word problems are going to have situations similar to this.